Okay, we're looking at a new test here, which is a ratio test. Ratio test is really just another way of looking at a geometric series and just extending it to finding the quotient of two consecutive terms, which is pretty much what we do with the geometric. As long as the two consecutive terms, the quotient or the common ratio is the absolute value of that is less than 1, then therefore we say the series converges. Similarly with the ratio test, it's just that you just do the absolute value, you do the limit as n goes to infinity as opposed to just any two random terms. But it's pretty much the same thing. It's built off that. You can show it converges if the ratio of two consecutive terms as n goes to infinity is less than 1. You can say the series converges by the ratio test. Likewise, you can say it diverges if the ratio as the n goes to infinity is bigger than 1 or infinity. That's divergent. And just like with the geometric test, if the common ratio is equal to 1, there's really nothing you can say about the series. So how do I know it's a ratio test? The real giveaway to me is whenever I see factorial. So let's just do a quick check on the factorials. N factorial is equal to n minus 1, n minus 2, n minus 3 times 2 times 1. So whenever I see factorial and I'm trying to show a series converges or diverges, it's ratio test. Okay, a ratio test you pretty much can use to show just about any series converges, but I pretty much do it exclusively for factorial scenarios. So all I really need to do is just show that the two consecutive terms, the ratio of it is less than 1, and show that it converges. So I have the limit as n goes to infinity. I just need to do 2 to the n plus 1 over n plus 1 factorial over just the nth term, n over n factorial. That's a factorial right there. Absolute value bars, absolute value bars aren't really that necessary because these terms are always positive. So I'm going to drop them on the next step. I'm going to rewrite this as the limit as n approaches infinity of 2 to the n plus 1 over n plus 1 factorial times, I'm going to flip and multiply, n factorial over 2 to the n. Okay, I'm going to go over here now, slide my paper up a little bit. This is the limit as n goes to infinity of 2 to the n times 2 to the first, right? So these two exponents, they add them, times n factorial all over n plus 1 times n factorial, right? Because this, I can break this up as n plus 1 times n factorial. I'll just peel off one of the terms and I'm still left with n factorial times, this is 2 to the n. That n looks a little sad there. Well, what happens? This cancels, this cancels, this cancels, that cancels. I'm left with the limit as n approaches infinity of 2 over n plus 1. This is not a L'Hopital's rule candidate because my numerator is not 0 nor infinity. Everybody should be okay with as n goes to infinity, my denominator is going to get quite large. So therefore, this is just going to equal 0. So therefore, this is a convergent. So this is by the ratio test. It converges. So we're all set.